In today's video, we are going to have a practice problem on how to find the antiderivatives of inverse trigonometric function, and we are going to explain in details how do we get the answer. So these are the formulas that you need to remember. The first one, the antiderivative of du over square root of a square minus u square is equal to arc sine u over a plus c. The second one, the antiderivative of du over a square plus u square is equal to 1 over a arc tangent u over a plus c. And the last one, the antiderivative of du over u times the square root of u square minus a square is equal to 1 over a times arc secant u over a plus c. So these are the formulas that you need to remember whenever you find the antiderivatives of inverse trigonometric function. So let's start and let's have an example. On the first example, what is the antiderivative of dx over square root of 16 minus x squared? So as you can see, the given expression is written in the form of the antiderivative of du over square root of a square minus u square. So the value of a square, that is 16, and the value of u square, that is x squared. So to find the value of a, let us square both sides of the equation. So the square root of 16, that is 4. And the square root of x squared, that is x. And that is the value of u. And du, that is the derivative of x, which is 1. So we are going to have 1 dx. So let us have the antiderivative of du over square root of a square minus u square, that is arc sine u over a plus c, or can be written as arc sine the value of u, that is x, and the value of a, that is 4, plus c, and this will be our answer. On example number 2, what is the antiderivative of 3 over 25 plus x squared dx? So to simplify the given expression, let us rewrite this one as 3 times the antiderivative of 1 over 25 plus x squared dx. And this one is written in the form of the antiderivative of du over a squared plus u squared. So the value of a squared, that is 25, and u squared, that is x squared. And the value of a, that is the square root of 25, that is 5. And the value of u will be the square root of x squared, that is x. And du will be the derivative of x, that is 1 dx. So therefore, we are going to have 3 times the antiderivative of du, that is the value of dx, a squared plus u squared. So the value of the antiderivative of du over a squared plus u squared, that is 1 over a arc tangent u over a plus c multiplied by 3. So let us have 3 and then 1 over a, that is 5, and then arc tangent u, that is x, over a, that is 5, plus c. And to write our final answer, this will be 3 over 5 arc tangent x over 5 plus c. And this will be our answer. On example number 3, what is the antiderivative of 8 over x square root of 4x squared minus 1 dx? So to simplify this one, let us write our given as 8 times the antiderivative of 1 over x square root of 4x squared minus 1 dx. So this expression is written in the form of the antiderivative of du over u square root of u squared minus a squared. So this time, the value of a squared, that is 1, and u squared, that is 4x squared. And the value of a will be the square root of 1, that is 1. And the value of u will be the square root of 4x squared, that is 2x. And du, that is the derivative of 2x, that is 2 dx. So let us divide both sides by 2. So dx will be du over 2. So let us have 8 times the antiderivative of 1 over x. So to find the value of x, let us choose this expression. So u is equal to 2x. Let us divide both sides by 2. So x will be u over 2. That is u over 2. The square root of 4x squared, that is u squared, minus 1, that is a squared. And then dx, that is du over 2. So let us cancel 2. And we are going to have 8 antiderivative of du over u square root of u squared minus a squared. And the value of this expression, that is 1 over a arc secant u over a plus c, and then multiply by 8. So this will be 8. And then the value of a, that is 1. 1 divided by 1, that's 1. Secant or arc secant u, that is 2x. And then a, that is 1 plus c. And to write our final answer, this will be 8 arc secant 2x plus c. And this will be our answer. On example number 4, what is the antiderivative of x over square root of 1 minus x raised to 4 dx? So the given expression is written in the form of the antiderivative of du over square root of a squared minus u squared. So the value of a squared, that is 1, and u squared, that is x raised to 4. And the value of a will be the square root of 1, that is 1, and u, that is the square root of x raised to 4, that is x squared. And then du, that is the derivative of x squared, that is 2x, and then dx. So let us divide both sides by 2x. Therefore, dx will be du over 2x. So let us have the antiderivative of x over square root of a squared minus u squared. And dx, that is du over 2x. So let us cancel x. And we are going to have the antiderivative of 1 over square root of a squared minus u squared multiplied by du over 2. So let us move this one in front. This will be 1/2 times the antiderivative of du over square root of a squared minus u squared. So the value of this expression, that is arc sine u over a plus c multiplied by 1/2. So this will be 1/2 arc sine u, that is x squared, a, that is 1, plus c. And to write our final answer, this will be 1/2 arc sine x squared plus c. And this will be our answer. On example number 5, what is the antiderivative of x over x raised to 4 plus 36 dx? So the given expression is written in the form of the antiderivative of du over a squared plus u squared. But I'm going to write this one as the antiderivative of du over u squared plus a squared, because I'm going to set the value of u as x raised to 4 to eliminate the variable x. So the value of a square, that is 36, and u square, that is x raised to 4. And the value of a, that is the square root of 36, that is 6. And the value of u will be the square root of x raised to 4, that is x squared. And du, that is the derivative of x squared, that is 2x dx. Divide both sides by 2x. So the value of dx will be du over 2x. So let us have the antiderivative of x over u squared plus a squared. Dx will be du over 2x. So let us cancel x and let us move 2 in front. This will be 1/2 times the antiderivative of du. So this time, I'm going to write as a squared plus u squared. They are just the same. So this expression, that is 1 over a arctangent u over a plus c, and then multiply by 1/2. And to write our final answer, let us substitute the value of u and a, that is 1/2, and then 1 over a, that is 6, arctangent u, that is x squared, a, that is 6, plus c. So therefore, let us have 1/2 multiplied by 1 over 6, that is 1 over 12, arctangent x squared over 6 plus c. And this will be our answer. On example number 6, what is the antiderivative of x cubed over x squared plus 1 dx? The given expression is associated with arctangent. And if we are going to set u as x squared, the value of u will be x. And we cannot eliminate x cubed in the numerator. So to simplify this one, let us try something different. So let us use a long division. Let us have x cubed divided by x squared plus 1. X cubed divided by x squared, that is x. And x multiplied by x squared, that is x cubed. And x multiplied by 1, that is x. So let us subtract. So this 2 will be cancelled. And we are going to have negative x. So therefore, let us rewrite our given as x minus the remainder x over x squared plus 1 dx. So we can separate this one as the antiderivative of x dx minus the antiderivative of x over x squared plus 1 dx. So let us rewrite the antiderivative of x dx, and this one can be solved using u-substitution. In u-substitution, whenever you have a fraction, the denominator will be the value of u. So the value of u will be x squared plus 1, and du, that is the derivative of x squared plus 1, that is 2x dx. So therefore, dx, that is du over 2x. So let us have the antiderivative of x over u multiplied by dx, that is du over 2x. So let us cancel x and let us move 1/2 in front. This will be the antiderivative of x dx minus 1/2 times the antiderivative of 1 over u du. And to simplify, we are going to have the antiderivative of x dx minus 1/2 times du. This time, let us substitute the value of u, that is x squared plus 1. So let us have the antiderivative of x dx, that is x squared over 2 minus 1/2, and the antiderivative of x squared plus 1, that is ln absolute value of x squared plus 1 plus c. So our answer can be written as 1/2 x squared minus 1/2 ln absolute value of x squared plus 1 plus c. And this will be our answer. On the last example, what is the antiderivative of e raised to 3x over 9 plus e raised to 6x dx? So the given expression is written in the form of the antiderivative of du over a squared plus u squared. So let us set a squared as 9 and u squared, that is e raised to 6x. And then the value of a, that is the square root of 9, that is 3. And the value of u, so let us square both sides of the equation. So the square root of e raised to 6x, that is e raised to 3x. And du, this will be the derivative of e raised to 3x, that is e raised to 3x, times the derivative of 3x, that is 3 dx. So this will be du equals 3 e raised to 3x dx. So let us divide both sides by 3 e raised to 3x. So dx will be du over 3 e raised to 3x. So let us have the antiderivative of e raised to 3x over 9, that is a square, plus e raised to 6x, that is u square. And then dx, that is du over 3 e raised to 3x. So we can cancel e raised to 3x and let us move 1/3 in front. This will be 1/3 times the antiderivative of du over a square plus u square. So this expression, that is 1 over a arctangent u over a plus c multiplied by 1/3. So let us have 1/3 and then 1 over a, that is 3, and then arctangent u, that is e raised to 3x over 3 plus c. And to write our final answer, this will be 1/3 times 1/3, that's 1 over 9, arctangent e raised to 3x over 3 plus c. And this will be our answer. So I hope you've learned from this lesson. Thank you so much for watching, and God bless us all.